All right, lesson 17. Let's graph some logarithms. This lesson takes a little while. So let's go. We're going to graph lots of things. We're not going to do it necessarily by hand, all of them. We're going to start off by hand. And then I'll show you a calculator-based approach, because this is the 21st century. This is not in your book, but this is just a little thing. You know this. Recall it, right? If you haven't gotten this down yet, that's not good. So, here we go. I have these tables of values. We are going to go ahead and graph them. All right, so let's just take a calculator approach to this. So go ahead and get out your handy dandy calculator. Hit y equals. Now we can hit y equals. Ooh. I actually have them there, but I'm going to go ahead and erase them, sorry. And go from scratch. So first thing we're graphing is log base 10, right? So all you gotta do is hit your log button, log base 10 of x. And let's go ahead and look at that. Alright, y'all, keep in mind, your calculator for some reason has it cut off. But what's really going on here is this keeps going on and on and on and on and on forever and ever and ever, okay? It will approach the y-axis, but it's never going to touch it. Why is that? Weird, right? It's because, is it possible to have, if we have log of x, is it possible for x to be 0? Or is it possible for x to be a negative number? No, it's not. Yeah. Right? Remember, we've already determined that you can't take the log of 0 and you can't take the log of a negative number. And that's the explanation for why the graph looks like that, right? Why it doesn't have values at 0 or lower than 0. Let's go ahead and graph. I'm going to show you two ways to do it. We're going to graph log base 2 of x. Now, if your calculator has the fancy operating system, you will go ahead and put math, and you can go to the very bottom there where it says log base, and it'll let you put a 2 in here and an x there. And you can hit graph. Again, that graph is also doing the same thing, right? It's going down, down and down and down and down and down forever and ever and ever. And it will get infinitesimally close to 0, but it'll never touch it, right? Like, in other words, the distance between the function and 0 is as small as you could ever imagine, like 1 over infinity small. 1 over a billion small, right? Bigger, like smaller than that, right? Like 0.000000000000000000000000001, like more than that, right? Like that small, tiny, teeny tiny. All right. If your calculator does not have that function, you can use the change of base formula to put that in there. It tells you that if I have a log base b of x and I need to write it as a log base, as a different base, I can write that as log base a of x over log base a of b. So in other words, if I want to write log base 2 of x in terms of log base 10, because I don't have that log base. I only have the log button, that's log base 10. I can put this in my calculator as log base 10 of x over log base 10 of 2. Really easy. X over b. Okay? X over b. So, I can go to my calculator and plug that in. It's going to be, so I'm going to argue that these two things are the same. That log base 2 of x is the same thing as log base 10 of x divided by log base 10 of 2. And I hit graph and look. Oh, that was cool. They're the same. Alright? Okay? So again, that's the formula that you'll use. If you need to graph it, but you don't have that log base function, that's how you're going to do it. Alright? We have one more to graph, and I'm going to go ahead and actually use it as a change of base. So I'm going to, do you remember we had to do log base 5? I'm going to write that as log base 10. So that would be log base x divided by log base 10, log base 10 of x divided by log base 10 of 5, right? That's log base 5. Log base 5 of x, that's what that is, okay? We hit graph, and there it is. And we have all 3 graphs. You don't need to do it by hand, in my opinion, because you should know how to plot points by now. Please God. I pray that you can plot. Okay? All right, let's go ahead and analyze that on this next page here. So you should have a graph that looks something like that. If you don't, put that on your graph. So match this up. I'll give you a moment, guys, to put these graphs in your book. Actually, we'll discuss the bottom here. Actually, the bottom is the answers to the questions that are following this in your, and I don't think that they're, are they there? They're there. So for number 1, what is your, on your next page there? Your book is asking. What does the graph indicate about the domain of your function? So here's your domain. And it's just as we were saying. We could also say for our domain that x is always greater than 0, right? Another thing we could say about that. So what does it say about the domain? It says that x is always greater than 0, right? Or it's on the interval. If you want to use the interval notation, you could use this one, right? Same with this one. Describe the x-intercepts. Do you notice? X-intercepts are always 1. Why is that? Why are x-intercepts always 1? Well, let's look at it. If I plug in 0 here, right? That's got to be 1, right? Because we could say that this says that 10 to the 0 power equals 1. That has to be the case, right? So it doesn't matter what the base is, right? I'm sorry, I meant to say... No. I did this wrong. Wow. Sorry about that. The x-intercept is at 1, 0, right? Is at 1, 0, sorry, and this is because 10 to the 0. Okay. All right, so there are no y-intercepts. That makes sense. So there on page 120 in your book, we're actually answering these questions, right? So C, there are no y-intercepts. For B, if we describe the x-intercepts, all the x-intercepts occur at y equals 1. The domain of the function is there, okay? So this box is just a shorthand way of writing all of those answers. For E, find the coordinates on the graph with y value 1. What that's talking about is this right here, all right? And it makes sense, right? For log base 10 of x, right? Log base 10 of 10 is 1, right? It's 10. So what power is 10? 1, right? Log base 2, right? Log base 2 of 2 is 1. Log base 5 of 5 is 1. All right, the answer to E, describe the behavior of the function as x approaches 0, okay? In other words, if x is going this way, right, as x gets closer to 0, what happens to y? Well, y keeps going down, right, or keeps getting more and more and more negative, yeah? So in other words, and you could also say for this one, right, for each of these, y approaches negative infinity, right? It's another way of saying that. Y approaches negative infinity. So as x gets closer to 0, y goes way down to negative infinity, right? So those would be the what you will write down there for E. For F, the behavior as x approaches infinity. Well, is there ever a point where this thing stops increasing? No, it just keeps going, right? So now we're saying as x goes this direction, what happens to y? It just keeps increasing. So let's go ahead and answer G. What's the range of our function? F, we did that. Describe the end behavior as the function. So I said, I was right as the phone rang. As x goes to infinity, f of x goes to infinity. Or and g of x goes to infinity. And h of x, in other words, y goes to infinity. As x goes to positive infinity, y goes to positive infinity. Okay. How about g on that? Describe the range of your function. Well, it's all real numbers, right? X can't be less than 0, but y can have all kinds of different values, right? From negative infinity all the way to positive infinity. So for here, we can say that for g, we can say that we can use a couple of different forms of notation. We can use some inequalities. And we can use also intervals. Y is on the interval from negative infinity to infinity. Okay? Or you can say that x is contained in the set of all real numbers. There's set notation as well for you. All right, and for h, does this function have any relative, maxima, or minima? And remember, for h, guys, a relative max looks like that, right? That's a max, and a relative min looks like that, right? In other words, a maximum occurs when your function changes from increasing to decreasing. A minimum occurs when your function changes from decreasing to increasing. Do any of these do that? They do not. They just constantly increase, right? Yeah. They never change from increasing to decreasing. So there are no relative maxima, or minima. Yay! And we explained it. Okay.